Hello?
Yes.
Can you hear me?
Yes, we can.
Hello.
Yes, we can
We
hear
can
you,
hear
but you can't
you.
hear us.
No, I don't know why not. Okay. Anyway, well, I have the honor to introduce Khushbu Kshirsagar. Um, she's an amazing person. Actually, we know each other for 2 months, not too much, but as soon as we start like sharing our perspective of how maker education can be really interesting into the learning part, and how can we design better learning experiences with digital technologies. I think so we understood very well. She's an engineer, also an educator and a researcher about hands-on STEAM learning. She is currently studying STEAM educator in Tufts University, and also he works as a researcher at the Center of Engineer Educator Education of Outreach. You will see that her work is amazing in terms of how can we apply creativity into design artifacts that allows us to learn. That I think is really aligned of the topic of this field activity. And nothing else to add apart of leaving her to explain her story and her, let's say, point of view of how to introduce digital fabrication into the curriculum. Thanks, Khushbu, to be here today. Welcome.
Thank you so much. And thanks for having me. Hi, Ivan. I see Ivan. I know Ivan too. But I just love this community. So, I'm very, very grateful that Santi gave me this opportunity. This is amazing. I am going to take a quick second to try to share my screen and get us started. Alrighty. All right. Can you guys see my screen?
Yes.
Yes.
Yeah. Okay, awesome. Okay. Alrighty. So hi everyone, my name is Khushbu, as Sandy just mentioned. This is so I'm gonna walk you through some of the stuff that I've built, but more so on how I think and what I build. It's going to be a little bit of a personal journey. So I'm going to share some vulnerable raw prototypes in hopes that they stay and stick with some of us who also tinker here, and also some of my rabbit hole explorations with certain projects. So hopefully I'll have enough time to show at least 3-part explorations, hopefully. If I'm rushing, and if you at the end want me to go and spend some more time in one of the projects, I'm happy to go back later on. But yeah, as Santi mentioned, my background is mechanical engineering, very fascinated by mechanical design and making mechanisms for the longest time. I worked in the industry after that, and I hated that because it was a complete disconnect between, what they tell you what industry is versus, what you learn as an engineer, and what got me excited at least. And so I switched to working for a makerspace. This was back in India, which is where I'm originally from. I worked for this makerspace called Makers Asylum, spent a lot of time very close to machines, building a lot of random things, but then pivoted into working as a toy designer for a STEM toy design company. This is where I kind of got into, play testing my ideas with 5, 6-year-olds that absolutely had no idea what Newton's laws of motion were. And then suddenly my mind was blown where I saw that, oh, wow, we black box so much. And play actually helps in unblack boxing a lot of those information or knowledge. And so I think that's kind of where I wanted to fuse a lot of my work around designing things that you can touch and move and play with from a mechanistic point of view, where you could, make things move using mechanisms, but essentially have, you know, uh, I don't know, talk about mathematics from an abstract concept, or like science almost, by inviting, open play. And so that's how I got into the world of STEM education, which is what I got my master's in. And currently, I'm a PhD student in learning sciences, and I mostly design tools and experiences that help in open-ended learning. My focus has pretty much been in out-of-school spaces. I'm interested in rethinking informal spaces such as makerspaces, libraries, your everyday public spaces, and how they can be transformed into, smaller portals of inviting curiosity almost, and how can physical design play a role in inviting this sort of a play almost in a hands-on way. But yeah, that was a long-winded, short blurb around, me and myself. If you're interested to see what kinds of projects I've built, this is the link to my website. I can put it in the end in the chat, so you don't have to like do that right now. But yeah, so in a nutshell, what I do is I design hands-on learning experiences, mostly at the intersection of engineering design. This links to a lot of mechanical design work that I do. And mathematics. I say mathematics, this is my personal interest because I have been introduced to mathematics from a very creative point of view and never from the sense of, walking towards the right answer. And so mathematics has always been a fun and a creative space for me. And art and engineering design are more so like the bridges to connect this abstractness that mathematics or engineering brings. And I'm trying to sort of find more ways to bridge that gap. So here's a little bit of stuff that I've built. I have the experience of prototyping from, materials like wood, metal, and somehow have found myself really, really fascinated by paper. Um, of course, like acrylic and, using a lot of rapid prototyping technologies. But I cannot emphasize enough on how much paper and paper engineering keeps blowing my mind. And I think you'll see a lot of it in some of the slides to come. So some of my early ponderings was, how do we think about constructive approaches to how instructional design works, mostly in STEM fields? And what do I mean by that? So for the longest time, I used to think about how do we learn in school or even as we grow up? What are some of the things that replicate instructional materials in our lives? So, naturally, some of them are books. I'm a millennial, so I definitely grew up referring to a lot of books. And I mean, I'm sure you still go to the library, refer books. This has taken the form of the internet, Google, whatever you might say. But also, like, if you look at, the second images from an IKEA instruction manual, how do you put together things? It's a very visual way of sort of step by step thinking about how do you put this thing together. And then essentially, the third thing is video tutorials or YouTube videos. So, when things break down, you kind of follow an instruction and a step-by-step instruction as to how to make things. So kind of trying to connect them around, like, how do we make things and how do we refer to things when we're actually constructing something? And so my pondering led me to sort of thinking about ways around open-ended learning and how do we actually make um, toolkits or avenues around free play, free making, and what does it look like to play with loose parts? So this is an example of what Cass Holman does, which is essentially, this is like a big construction playground set, which is human scale linkages. This is what that is. And kids can come together and put pieces together and make their own version of, I don't know, like a toy or a house sort of. And then the other one here is a Lego brick setup where, one of my professors used this, where you can use whatever electronic parts you want, but make a robot that walks in a silly way. And again, so this does not really follow a linear set of instructions, but offers like toolkits for you to explore in a way as to how you want to put things together and make your own things. So one might wonder, like, what is the need for an open-ended, constructive way of instructionism, if that's like name dropping a few terms here. And so some of the things that have particularly stood out to me have been this idea of accessibility and the idea of entering in with a low access or like low entry to barrier point. So I feel like there is a need to have more learning tools that need a low skill or like a low access to entry. And then the other one is tools that can yield a lot of learning opportunities, not just one thing, but how can a tool sort of offer a lot of things to do that is not necessarily prescriptive or instructional. Like you're not doing you're not following a step-by-step thing like you would in a DIY video maybe, but how do we offer more ways to sort of think in a three-dimensional sort of a way? And so that's how I made one of my very early. So this is, again, like I said, this I'm going to be sharing out some very vulnerable early prototypes. So here's an early prototype of something called the Zine machine. The idea was to translate big ideas in mathematics into paper form. So it's a little booklet that can be folded into which can be folded from a flat sheet of A4. So there you go. It folds into a small booklet, which you can flip through and has some narratives written as to how to use this book. It has some, laser cut pieces that are machine components that you can take out and assemble on the back side of the sheet when you open, which is the maker canvas. And the idea essentially is that you make machines that move. So these are some of the user outcomes that came out. I'll let you guys watch and then talk a little more. So the idea was essentially to like rethink ways of folding paper so that you can make your own little booklet that does more than, just have text on it. And so what I essentially did was took a thick piece of, your printer paper, your regular A4 size paper, poked holes through it in a grid format, and then tried to fold it into a zine. Which is, like I said, so you fold an A4 size paper in a way that it kind of closes into a booklet. If you don't know what a zine is, it's essentially, it used to be used as a way of activism and protesting earlier, and it used to be, a form of sort of putting collages together and sharing out ideas in a more democratic and free form way. So that was an inspiration for me to talk about, how do we bridge mechanisms in mathematics in a paper format almost. And the idea was also like to think about storytelling or narratives, but in a more sort of animated form. And so mathematics, how? So the kit comes with a prefixed input, which is the circle here. And the idea is that you're supposed to be making your own connections onto this input. And, so the idea was to translate the function equivalent, which is the y is equal to f of x algebraic function, where x is your prefixed input. And then the f of x would be the combination of, linkage systems that you build on this input. And then the final output would be the final motion that you have as a deliverable. So some of the user creations that came out were here. So, as I mentioned, I have been running most of my stuff as a research study, essentially in the form of, getting user feedback. How did this stay with the participants who used it? And so some of the people, so about 15 people tried this kit out, and I conducted some Zoom interviews asking them, what stood out to them. I did not want to like throw in the word mathematics into their mouth. And if it didn't come to them, it's totally fine. And so it was surprising to see how some people did talk about mathematics. So for example, this person here is a mathematics PhD person and was trying to like, map out the locus of some of the points in their linkage system, which was fascinating. And this was probably, by reading the text on the zine. But then this was a 7-year-old here who was trying to, make a robotic arm and was using colored pens based on the colored fasteners here, and was like, oh, I'm going to mimic a robotic linkage arm. And but some of the projects were pretty much free form, expressing their own imagination and creativity on this canvas, sort of an exploration. But going a little deeper into the research, here is some of the data analysis or some of the broader categories that came out from what people said during their interviews. So I paid attention to particularly some of the learning outcomes that people mentioned. You know, did any of the math concepts show up? Did any of the, you know, mechanism making show up? Was it, you know, was it intuitive enough for them to make something move, especially on paper, because you don't really see linkages on paper per se. The second one was usability. Was it easy to use? Was it annoying? Did they use a lot of like self-expression, or did they, you know, did they make their own add-ons? And finally, user engagement, you know, some very specific, very straightforward questions like, did you have fun? Or was this, you know, frustrating? Or, you know, sort of assessing the number of like hours or number of minutes that they spend. So like some people spent about half an hour, but some actually did spend an hour and a half trying to figure out what they wanted to make. And these were some of the outcomes. So this is a little bit in detail. I won't go, I'm happy to revisit this later, but again, from a data visualization point of view as to what people said, you know, the dots are essentially the number of, so for example, here, about 6 people found building mechanisms challenging. About 3 found them easy to use. And, you know, essentially this is a deeper dive into, you know, what came out out of the data analysis process. But yeah, this is kind of you know, me trying to branch out a little more on the paper mechanism part, and then I was trying to build a board game with paper mechanisms, and this was a pilot study I ran with some high school students. Always open to, you know, it's I think paper offers so many opportunities to sort of take it to another dimension, and is low cost and is a low entry to barrier. And low barrier to entry, and so, you know, like I said, always fascinates me in ways that people use it, and in ways that people actually don't know how to use paper. And there's this layer of sophistication where, you know, paper is often thought of as a craft material versus not as a sophisticated engineering material. And so how can rapid prototyping really help in bridging that gap, is something that I'm really, really interested in. But yeah, that is the end of part 1. But essentially part 2 is, you know, going back to my original thought around how do we design for inviting curiosity, which is what I'm really, really interested in right now, even as a part of my research. And it starts with my own journey of, you know, being fascinated by this math exhibit, which depicts the Pythagoras theorem purely by, you know, movement. So you spin this circle and you see the fluids sort of transferring from one square to like the other 2 squares, and it's essentially a visual proof of the Pythagoras theorem, which is the a squared plus b squared is equal to c whole squared. And this blew my mind because, you know, hey, you could actually visualize an equation with the form of a movement. And so, you know, this was a very early on a rabbit hole exploration journey for me. And so, you know, again, for my research work, I've been interested in thinking about what and how can we invite curiosity through the artifacts and the tools that we build as learning designers, and what are some of the characteristics of these of these physical designs particularly. So I'm going to quickly take you on my personal journey. So I, for the longest time, have loved how tessellations work or tilings work. So, you know, these are some examples of certain shapes tiled. And when I say tiling or tessellation, that means they leave, when stacked next to each other, they leave no gaps in between. And again, as someone who's always been fascinated by movement and mechanical motion, I kind of wanted to make them move. So, you know, I turned it into a kinetic sculpture. And while I was making this, you know, this brought me to think more about the mathematics in the making of something like this. And I was really, really excited, and I wanted more people to think about the small relationship that it boils down to when you actually try to make something move like that. And it was really, really simple. And so in an attempt to do that, I tried to play with the scale of this. So this was a tabletop version. And I thought that, okay, what if they played with a smaller fidget toy version of the same thing? So I shrunk this down and made this into a desktop toy version, hoping that they would see the patterns and that would, you know, make them. So by them, I mean more people who saw this, AKA users, or, you know, people who, I don't know, had. So this was actually a product that was sold in a museum store. So I was hoping that people would, you know, be more curious about how is this happening? You know, can I make this? And so again, you know, kind of going back on the lines of scale, this was a bigger, large scale model of the same idea where I thought that, okay, what if you stood on it and you moved? Would you be able to see patterns more clearly then? Would this bring more curiosity to, you know, understand how this is being made? Full disclosure, it did not. They were mostly just fascinated by the movement and in all the three scales. And so that to me was a little unsettling. And I'm trying to like get okay with that frustration that it's okay if it doesn't, you know, convey the math idea. But you know, my explorations didn't stop there. So I again went back to paper in hopes that, you know, maybe it's the material that was acting as a barrier. And what if paper offered more ways to sort of get into the understanding of, you know, the moving of sort of shapes and similar mechanisms. So this is the same kinetic sculpture, but not with hexagons, with squares. And, you know, people were invited to sort of play with this. And you know what? It still did not go to the mathematics direction. But then I pivoted towards converting them into blocks. The plug and play model of the same kinetic sculptures. So I built 3 different types of shapes. So here you see a square, a triangle, and a hexagon somewhere here. And I you know, 3D printed some of the connectors that mimicked the original sculpture in hopes that if they actually constructed this sculpture from scratch and saw it move, maybe that's what's going to make them curious about the tessellation bit. But again, I think movement took the upper hand, and these are some of the creative sort of outcomes that people created. So these designs were tested in 2 different settings. One was in a museum hallway, and then the other one was at a 6-year-old's birthday party. And so the left one is the museum setting. This is from one of the birthday party kids. Oops. But yeah, so I think what it led to was some did actually try to mimic the kinetic sculpture bit, but some also were interested in abstract creation of, you know, organisms or animals. And it's, I think it just is, it gave me the opportunity to be okay with this idea that yes, okay, people are building and playing, and it does not have to, you know, be hardwired into a math concept. And it was really, really freeing. But yeah, that was, I would say that was the end of a rabbit hole journey with shapes.
Khushbu, I
But
wanted to jump in here real quick. We're running low on time, so
that's what I figured. Yeah,
okay,
yeah,
all
yeah.
right.
Okay,
If you
so I
want to
wasn't sure if we were gonna get time to do this, but
if you want to rush through these last slides, I'm not sure how much time we'll have for questions and answers, but this is fascinating. So make these go fast. These last few. We'll have
okay, yeah. So
Thank you.
I really wanted to focus more on the first and second, but I'll, you know, in a nutshell, try to talk about this. So finally, you know, what I'm doing right now, this is like, you know, my current work, which is a collaboration with Microbit. And it is to kind of fuse picture books and interactivity using, you know, Microbit sensors into comic format and like interactive narrative storytelling format. And again, this is laser cut paper. So again, trying to use rapid prototyping on paper to make it look or like make it give an aesthetic of a sophisticated prototype of a sort, of some sort. But here's a demo of what I mean by that. So there's a sound, and I don't know if you can hear the sound, but it's supposed to, you know, show a sound. But okay, so yeah, so when you press buttons, it's supposed to do something, you know, and then the idea is to use cutouts to sort of make the use of the microbit board. And again, going back to the modularity things of rapid prototyping. So this was all glue-free assembly, and I have been running workshops in this, especially around this, where like people are building their own little storybooks with microbits. And so a lot of it is, I'm gonna totally speed through this. But yeah, so the idea is, so this is what usually participants are given. These are pre-cut out templates for their, you know, storybooks. And here's some creations that I think are really interesting and worth seeing. A, B. It says nom nom. It says nom nom. This is another one on cats. 2 cats. But yeah, this was like a workshop that was 90 minutes. These people had no prior experience of working with a microbit. And so, you know, it was really, really fascinating to see how the blend was almost natural. So there's a sound there. But yeah, so roughly the idea is to, you know, look at intergenerational collaboration when it comes to the use of paper and electronics and something as accessible and easy to enter with microbits. But yeah, um, you know, I really want some, you know, Q&A time. So happy to talk more. Again, this is my website and I can also drop in my email. But yeah, please, I would love to hear what you thought, and I hope it wasn't too rushed. And yeah.
No, thank you so much, Khushbu. We're going to do about 5 minutes of question and answers, and I've got to get this question in here first. First of all, I wanted to point out that your all of this amazing engineering with paper is fascinating and something that really lowers the entry bar, like you were saying. And it's relevant to what we're doing as well in this class, designing things for people to use in order to learn. But I think my question is specifically about the learning objective that you have, or the objective you have to kind of ignite curiosity. And it's helpful for you to share how really that, you know, there was failure here, failure there. I mean, from that learning objective, right? They're more fascinated with the motion than the, you know, curious about how the shapes combine. But how in those tests are you measuring curiosity? How is that something that you measure?
Yeah, so that's a great question. So from what I've identified so far which is why I shared the framework early on. I can go back to it, but the idea essentially is that so I've been looking into a lot of neuroscience, cog-sci work, which is very much around like how do people behave when they're curious. And so a lot of it is, you know, trying to bridge an information gap or trying to look for that novelty sort of an experience. So what stood out necessarily from some of the research studies that I conducted were like 5 categories. One is, you know, this draw or appeal to sensorial um, um, uh, elements almost. And so, you know, that could be like if it has a sound, like there's an immediate like draw towards it. So like, I mean, there was definitely like some tests that I conducted around like, so what was there like an observation around, you know, okay, was there a distraction if they heard a sound? Was there a you know, was there a particular appeal to movement clearly because of the kinetics of it? And so that, and then the other one was social interaction. So a lot of the curiosity was, you know, came in from this environment that they were in. So, hey, did you see this thing? Or like if someone was building something, they would like look at the other person's thing and be like, oh, I want to build something similar, or I want that piece, especially with the blocks. That's what I saw a lot with the 6, 7 year olds that, oh, I see that crab movement. I want to make a crab. And you know, especially like going back to the no instruction manuals sort of a thing. And you know, these are not your usual Legos, but then just like 15 minutes into building, this one kid shows up and is like, oh, I know how to make like a dinosaur. Let me show you how to make a dinosaur. And so again, like how do you the familiarity of it and like being able to talk through that was something that stood out, and I have been using that as a measure. The other aspects are actually accessibility as well, like what gets you started to like fail early. So like fail super early and you know, get things broken or like taken apart so that it's easier to get into the rabbit hole exploration almost. And so a lot of it is, so I'm particularly focusing on the physical aspects because so much exists on the behavioral side. So I'm going to go back to that framework real quick. There you go. So again, you know, the invitation being so almost on like, so what is challenging for someone, you know, and again, this is so broad that it is very hard to sort of funnel it into a physical thing. And so that is kind of what I'm trying to tackle, like what would a framework for physical design really look like, where you know, you are able to like have enough trust. And so the failing early kind of falls here, because then you're trusting the process, right? Because, oh, I failed and now I know how this works versus what doesn't work. And then when it actually works, it kind of brings this surprise element. So yeah.
Great. That's awesome. Now I see why you and Santi clicked so much. You've got these cool graphs that Santi likes to do in all of his things. We have time for another question. Does somebody have a question for Khushbu? or a comment? No?
Yeah, I have one. So thank you very much for the presentation. And I'm interested, have you had any collaboration with teachers? What is their perspective on all the projects that you have been involved in? Have they participated somehow?
Yeah, that's a great question. So I think the zine, the earlier one, I had some collaboration with teachers. The idea was to send them templates because, they don't need a lot of materials for it. And even if they have a small Cricut in their classroom, they should be able to like print it out. And I think what was interesting, so I think the zine really stood out to them in a way that they could, so a lot of people used it as a stencil to make drawings or like to convert it into drawing machines, and a lot of it was done around mechanism building in their classrooms. And I think the idea, so what was told to me as a feedback was the pocket sizedness of the zine was a really cool feature because they could put it in their pockets and like show it to their friends, and so the sharing of what they made really stood out to them. I think there were definitely asks from what I remember around how do you build a curriculum around it, really, especially like if it's mathematics driven and if there's a goal to follow. I think there was an ask to sort of have pages or modules around, okay, so this small version is just going to talk about one sort of motion, and then the other one is going to talk about just the other kind of motion. And so that was the other interest point. But really the most, like I said, I personally live a lot in the informal space, and so the idea is to put a wall of like mechanisms and see what people are building on top of it, and can it be replicated in classrooms or even at their homes, because again, this is paper, and so materials that they find easily in their homes. But yeah, I think mostly it has been these interactions with teachers that are that showed up at conferences, or I had given out a few copies to a few teachers, and then they tried it in their classroom.
Great. Thank you so much. We really appreciate you. What inspiring presentation.
Thank
And we
you.
really appreciate you sharing your early failure as well. We love to see that.
Thank
So
you.
thank you. And applause for both of our speakers. I want to say we really appreciate you both sharing today and responding.